So question number 1A, back on page 2, asked to use the periodic table on 497 to calculate the relative formula masses of the following. The first one they ask you to do is calcium chloride. So what I did was I went to the back of the book and I got the values for calcium and for chloride. So for calcium, the back of the book lists it at 40.1. Okay, since there's only one unit of calcium in that molecule, I only need to multiply by 1, so I'll use this value. Chlorine, however, is listed at 35.5. And in the compound, there are 2 of them, so I have to multiply by 2 to get 71. I then have to add these 2 values together to get my final formula mass, which when I add is 111.1. And again, like I said, there are no units right now. Okay, so if you get a final answer, if you use that periodic table there, you should get something close to 111.1. Okay, so I understand, I did say you could use that. I just used the values from that table. But again, you should be relatively close. All right. Next one is copper 2 sulfate. So again, using the values from 497, we have copper, which there's 1 in the compound at 63.5. We have sulfur, which there's 1 in the compound at 32.1. And oxygen, there are 4 in sulfate, so I have to do the value 16.0 times 4, which gives me a value of 64. And then again, I have to add all these together, and when I do, I get a value of 159.6. Again, if you use that periodic table, you should be close to 159.6. So we've got 159.9, 158.2. You're somewhere in the range, which is okay. All right, moving on to number 2 in the checking up. Okay, the first question, 2A, asks you, using the mass spec data of germanium listed below, you need to write the isotopic formula for the heaviest isotope. So remember, I look at my x-axis. The x-axis gives me my masses. The largest mass is 76, so I need to write that formula. So again, I start off with my symbol being GE for germanium. What? Oh, okay. So we have GE. I use the mass on the bottom, which is 76, and remember that is my nucleon number, so that goes on top. On the bottom would be my proton number, which is 32. Now again, we've learned that proton number is atomic number, but again, this is where we're trying to stay specific to Cambridge. Yes. 76 is the heaviest mass on the mass spec data right there. 74 is the most abundant. Yes, so here it doesn't say for the most abundant, it says for the heaviest. Yeah, so whichever has the largest mass. So in this case, that's a good question though. It can be confusing. And that's where the trickiness is in the words with Cambridge. It asks for the heaviest, so that's where I would just find the heaviest mass. If it asks for the most abundant, I would look at which has the largest percentage and use that mass. Okay? For the second part now, it asks you to use the percent abundance of each isotope to calculate the relative atomic mass. So again, to calculate the relative atomic mass, we have to use all of the data from the mass spec. So my first mass is going to be 70, and I'm going to multiply that by the percentage, 20.6. My second one is going to be 72, and I multiply that, stay consistent here, I multiply that by 27.4. My third one is going to be 73, and I multiply that by 7.7. My fourth one is going to be 74, and that is going to be multiplied by 36.7. My last one is going to be 76, and I multiply that by 7.6%. Now, when you check these values of percentages, they do add up to 100. So I have to divide by 100%. Okay, now I'm going to go to the next slide here. When I multiply all of my values up here, I get 1442 plus 1972.8 plus 562.1 plus 2715.8 plus 577.6. When added together, these all give me a grand total of 7,270.3. I need to divide that number by 100. So therefore, my relative isotopic mass would be 72.7. Okay, I've told you guys to round to 2 decimal places, so it'd be 72.70. All right? Are there any questions on that?